diode based rectifier. Now let us see what if we want to have a thyristor here, so that we could have some control on the angle. So for it, let us delete this one, and here you can see there is a thyristor available here. So if I click it here and we put it here, it is just as simple. I have just replaced this diode with this, and before that let me have this thing here, so that I'm more interested in getting to know what is the AC current here. Now we have to turn this on. This turning on means that this has to be turned on at specified interval if you want to get some output across the load. So for this, there is, you can see here, there is one block available here. This is the gating block for the switches. Now if I just click it here, you see it is available here. And sometimes with some circuits, it is this line is green line. If you are having that green line, just place this on-off switch controller in between this gating signal and the device, and it will work fine. So if I double click here, you can see here here is the frequency. Now since it's a thyristor, I'm not having this gating signal with the MOSFET, so this should work with the line frequency. So let us first convert this into 60 Hertz signal, and then we have number of 2 points. I just need to turn it on. Now my first, if I turn on the switch for a small interval of time, it will turn on as long as we have a positive half cycle on the anode of this thyristor. So this means that we are not forcing it to commute. It will naturally commute. So a very small pulse is required. So if I just put this 0 here, and a small pulse mean, let us put a 5-degree pulse here, it will give us exactly the same value as the diode. Let us see how. Now if I click it here, we just need to know the VP1, the load value. What you can see here, this is exactly what was produced by a rectifier, which was an uncontrolled one. And if I put this VAC here, you can see this waveform and this waveforms are of same value. Why? Because at exactly 0 degree you are firing it. Now let us suppose that we want to have a 45-degree phase difference, a firing angle of 45 degrees, so that the device will conduct after the 45 degree of each positive half cycle, and only for the positive half cycle, because this is a half bridge rectifier. So what I will do is this: I will put it 45 and make it 50. So just this, even if I make it 47, this 2-degree pulse is enough to turn on this switch perfectly. Now if I turn this on, you will see that the VP1 will not be exactly the one we have seen for the diode based rectifier. So you can see here there is a delay of 45 degree. Okay, now if I want to have a delay of, if we want to have a delay on even more, we can have it, for example 80, make it 85, and you can see here it will only it will clip a majority of the input waveform and will give us a value which is like this. So that is how you can control the firing angle of a thyristor here. So this is all for this tutorial. I hope you enjoy it, and stay in touch, stay glued with my channel. Inshallah, we will be having we will be discussing how we can use a photovoltaic modeling in the next class.